For monoatomic is 5 by 3, diatomic is 7 by 5 and triatomic is 4 by 3. From solid to liquid it is melting point. From liquid back to solid it is fusion, but from liquid to gas it is vaporization. Latent heat is nothing but the heat energy which is supplied during the change of state. Hello everyone, I am Brinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 3 of chapter 11, and the chapter name is Thermal Properties of Matter. So in last class, we winded up by studying the gas laws. In today's class, we are studying the specific heat capacity of gases. So now let us consider the specific heat capacity of a gas. So here at constant volume as well as constant pressure. Here in this case, we are keeping pressure as well as volume to be constant. So volume is said to be constant here and pressure is said to be constant. Then the specific heat is mentioned by a symbol, that is C. At constant volume is CV, and at constant pressure it gives Cp. So we have the specific heat capacities at constant volume and constant pressure. It is given by CV and Cp. Here the specific heat of a gas at constant volume is defined as quantity of heat which is required. You want certain amount of heat which is required to raise the temperature of unit mass of a gas. So here we consider only unit mass of a gas and the quantity of heat which is required to raise the temperature of this amount of gas through 1 Kelvin. Through 1 Kelvin is said to be specific heat at constant volume, because here we keep the volume constant. Therefore, the amount of heat which is required to raise the temperature of unit mass of a gas by 1 Kelvin, keeping volume constant. If the same definition is copy-pasted to the other one, wherein you will keep the pressure constant, then it is said to be specific heat capacity at constant pressure, which is given by Cp. So I hope you are clear with specific heat capacity of volume as well as specific heat capacity of the pressure. So after this, let us check into molar specific heat at constant pressure. So here, what is that molar specific heat? So the definition for specific heat at constant volume as well as constant pressure is nearly the same, but the constant what you're keeping will be either pressure or volume. Here we consider molar specific heat. There we considered unit mass of a gas. So there it was unit mass of a gas. So just discard the unit mass of a gas and induce mole. That is, here you're considering 1 mole of a gas. Exertion of heat to 1 mole of a gas through 1 Kelvin is said to be keeping pressure constant. That is said to be molar specific heat at constant pressure. So at constant pressure, what is the molar specific heat? Why do we call as molar for this specific heat? Because the gas particles what you're using is just 1 mole of a gas. So here 1 mole of a gas is taken as a sample and there is an induction of certain amount of heat through 1 Kelvin at constant pressure is said to be molar specific heat at constant pressure. Next, let us move to molar specific heat at constant volume. So in this case, it is like here we are keeping volume as constant. Keeping volume as constant, we define it as amount of heat required to raise the temperature of 1 mole of a gas through 1 Kelvin is said to be molar specific heat at constant volume. Okay, here what do? We keep the constant as volume. Previously it was pressure. If it is pressure, we term it as molar specific heat at constant pressure. If it is volume, we term it as molar specific heat at constant volume. So what happens in this case, that is, it is defined as the quantity of heat which is needed in order to raise the temperature of the 1 mole of a gas, whatever we consider, through 1 Kelvin is said to be molar specific heat at constant volume. So that is all about your specific heat capacity of gases. Here is a specific heat, whatever we consider. So there is an instrument in order to measure the heat, and that instrument is known as calorimeter. So here we have the molar specific heat capacity. So what do we do here? We find out the ratios of the specific heats. So ratio of the two specific heats, so Cp by Cv is nothing but it is given in this form, that is gamma. Gamma is equal to Cp by Cv. This is nothing but the ratio of two specific heats. So it always depends upon the atomicity of the gases. So how it depends on the atomicity of the gases? So we have got monoatomic gases, diatomic gases and triatomic gases. So for monoatomic gases, we have got it as 5 by 3. For diatomic gases, we have got 7 by 5. And for triatomic gases, we have 4 by 3. So these are the values of gamma, that is ratio of specific heats in terms of constant pressure and constant volume, and in terms of atomicity we have for monoatomic is 5 by 3, diatomic is 7 by 5 and triatomic is 4 by 3. Having all these concepts, let us study regarding the device which is used to measure the heat, that is calorimeter, and the method of measuring the heat is known as calorimetry. So what do we do here? The main principle of this calorimetry is the heat lost by the hot substance is equal to the heat which is gained by the cold substance. So what exactly is this calorimeter? It is nothing but just a copper vessel which is given with a copper stirrer. So why is this used? It is used in order to measure the heat of the substance with respect to the surrounding substance. So how the heat from the hot substance is transferred to a cold substance. Heat is a form of energy, wherein this energy is neither created nor it can be destroyed, but it can be transformed from one form to the other form. When this mechanism happens, what happens to the hot body? It loses its hotness and it moves to coldness, that is a cold body, correct? So what happens to the body which was hot and which was cold? Both also attains equilibrium. Until and unless it attains equilibrium, the hot body, that is a hot substance, keeps on releasing its temperature, while the cold body gains the temperature, gains its heat, correct? So this is what it is all about, the calorimeter's principle, that is the heat lost by the hot substance is equal to heat gained by the cold substance. When it is done, that is not the complete transformation of the cold substance into hot, but both also will be in thermal equilibrium. That is all about your calorimetry. Now coming on to change of state. There are three states of matter, that is solid, liquid as well as gaseous state. So when there are three states of matter, there is interchange between the states of matter. This transformation in the states of matter is called as change in its state. Okay, so here there are three types of states of matter, wherein solid, liquid as well as gaseous states. So here that is the change of state from solid to liquid, melting, and the change of state from liquid to solid is called as fusion, because the change from liquid to solid is said to be fusion. Its state of matter from solid to liquid is said to be melting point, and again from liquid back to solid is said to be fusion. It is fusing up. The components are fusing up. That is called as fusion. Now again, the change of state from liquid to vapor is called as vaporization. So it vaporizes. Such a process is called as vaporization. So you know that from solid to liquid it is melting point. From liquid back to solid it is fusion. But from liquid to gas it is vaporization. And the third point, you have got the temperature at which the liquid state and the vapor state of a substance coexist. Okay, so what is the boiling point of a water? It is 100 degrees Celsius, after which it starts vaporizing. So that coexisting point is there, no? That point is known as boiling point. So what is the boiling point of water? That is 100 degrees Celsius. So it is called as boiling point. And the change from solid to liquid, when there is changes from solid to liquid, that is solid starts melting. That change at that point from where the solid melts is said to be 0 degrees Celsius. So that is termed as melting point of a solid. And here we study regarding sublimation. So what is this sublimation? It is a direct change from solid state to gaseous state without turning into liquid. So it is the change from solid state to vapor state without passing through the liquid state is said to be sublimation. So you got to know what is meant by melting point, what is meant by melting, what is fusion, what is vaporization, boiling point, as well as sublimation. So that's all about the change of state of matters. And now continuity of the same concept is like latent heat. So what is this latent heat? Latent heat is nothing but the heat energy which is supplied during the change of state. When there is change of state, that is from solid to liquid and liquid to gas, the heat energy whatever is present, that is said to be latent heat. The heat energy which is supplied is said to be latent heat when there is change in state of matter. So the quantity of heat required to convert unit mass of a solid, we are considering a solid over here, so unit mass of a solid at its melting point. So whenever we consider, we have got our solids which is getting converted to liquid and again it is converted to gas. When there is a transition from solid to liquid, what happens to that point? And this point that is at 0 degrees Celsius, it is called as melting point. When there is transition from liquid to gas, that is when it transits from liquid to gas, that is at boiling point, at a point called as boiling point, after which the liquid starts vaporizing. That is at 100 degrees Celsius. So you have got your boiling point to be 100 degrees Celsius. So it is that the quantity of heat required to convert unit mass of a solid, conversion of unit mass of a solid into liquid actually. Okay, so conversion of solid to liquid at its melting point is said to be without change in its temperature. There won't be any change in temperature, okay? There will be no change in temperature. The only changes takes place in the heat which is provided. So I told you the difference between heat as well as temperature. Temperature is nothing but the hotness or the coldness measured by the body. So here the temperature, there is no change in temperature, but it starts melting. Why? Because of the heat supplied. So the quantity of heat which is required to convert unit mass of a solid at its melting point completely into liquid is known as latent heat of fusion, and most important thing is there is no temperature changes. Again, the next one, that is in order to study latent heat of vaporization. Fusion means something with regard to solids. When it comes to vaporization, it is nothing but liquid turning into gaseous states. That is the quantity of heat. Again, here also the requirement is heat. Heat is required to convert unit mass of a liquid at its boiling point. Liquid always boils, it doesn't melt. So we are mentioning at its melting point completely into vapor state, that is gaseous state, without change in temperature is said to be latent heat of vaporization. So these are the two concepts under latent heat. Latent heat of fusion as well as latent heat of vaporization. So that is all about this latent heat, and next going on to heat transfer. So as we all know, there are three modes of transferring of heat. Okay, what are those three modes? That is always the heat is a form of energy. It can neither be created nor destroyed, but it can be transferred from one form of the energy to the other form of the energy. So here we have got three types of modes of transfer of heat, that is conduction, Secondly, convection. Third is radiation. So these three are the concepts of transfer of heat by three different modes: conduction, convection and radiation. So let us look deep into it, that is conduction. So what is meant by a conduction? Conduction is a process where the heat transfer in solids from a point of higher temperature to a point of lower temperature takes place, where the movement of the particles of solids are not present. So you can see a person holding a pan which is filled with a liquid full of water, that is, the pan is filled with full of water, wherein the heat is getting transferred over here to the vessel. The vessel at the bottom starts boiling, which transfers its heat from this level to the cold region, heat to cold region. So conduction is a process where there is heat transfer in a solid from a point of higher temperature. Here there is a higher temperature to a point of lower temperature, that is a cold body. Without actual movement of particles, there won't be any movement of particles over here. So such a process is called as conduction. So I hope you're clear with what is meant by conduction. When you're clear with what is meant by conduction, the same image goes for convection and what is meant by convection now. Convection means it is a process in which there is heat transfer from one place to the other place. That one place is nothing but higher temperature region to a lower temperature region. By how? In the last condition, that is conduction, there was no particles movement, but here in convection, that is first conduction takes place, then convection takes place. That is, conduction means initial stage wherein you're heating a liquid, so that once the heat is gained by the vessel, it transfers its heat to a low temperature region, that is cold substance which is present within the vessel which is hot. Okay, so that is all about conduction. Once the complete liquid is boiled, what happens there? It starts boiling layer by layer, that is due to the particles, that is the bottom layer of the liquid gets heated up, it moves above. Again, whose density is more, gets back to lower region, and then again it gets heated up, again moves up. It is the same manner, that is, there is a movement of particles. Here convection is a process in which heat is transmitted from one place of higher temperature to a place of lower temperature. By how? By bodily movement of the heated particles. There are movement of the particles, that is heated particles, because of which the complete liquid gets heated up. Okay, so this is all about the convection. The heated water goes up and the rest, that is the lower temperature liquid, comes down and gets heated up and it goes back. So this is all about your form of convection. So this is one of the mode of transferring your heat. Lastly, we are studying regarding the radiation. So what is meant by radiation? Radiation is nothing but the process of transmitting heat from one place to another place without any aid of medium, transferring medium. Okay, so there is no medium as such here. So this is the radiation which is given out by the component what we are using in order to heat the substance, that is the releasing of radiation. So you know three modes of transferring heat energy, that is conduction, convection as well as radiation. So in today's class we have studied regarding the specific heat capacity of gases under constant volume and constant pressure. Then we studied about the molar specific heat capacity, where we consider the amount of heat which is required in order to raise 1 mole of a gas through 1 Kelvin at constant pressure as well as volume. At both conditions also we studied the molar specific heat. Later onwards we studied the relation between the ratio of specific heat at constant pressure and specific heat at constant volume. And how does it behave? It behaves under the atomicity for monoatomic gases, diatomic gases and triatomic gases in a different ways. After which we study the calorimetry. That is a method wherein you can measure the heat of a substance by using a instrument, that is calorimeter. It is a device which is used in order to measure the heat and coldness of the body. That is, what is the principle of calorimeter? It is nothing but the heat lost by a substance is equal to the heat gained by a cold substance. So that is all about the principle of calorimeter. Later onwards, we studied regarding the melting point, fusion, boiling point, how does it melt, sublimation, all these. After which, we actually studied about the latent heat of fusion, latent heat of vaporization. Finally, we got back to the change, that is mode of transferring your energy, that is heat energy. There are three modes. So it is conduction, convection as well as radiation. So here I defined for conduction, convection and radiation along with the images. So I hope you're clear with these many concepts under thermal properties of matter. Let us continue with the furthermore concepts under the same chapter, that is thermal properties of matter, in our next session, that is session 4. Until then, have a good day. Thank you.